Hi, welcome back to my class in Mathematics in the Modern World. For today, we will hopefully complete our example for balanced transportation problem. In the last lesson, we developed the second transportation table from which we developed the second transportation plan in which we obtained the second transportation cost of 3,502 pesos. And this was the second transportation table we developed from the last lesson. And today we will continue and we will check if we can still make the second transportation cost lower. And we will do that by test for improvement, in which we will consider again the vacant cells. And we start with this vacant cell XB, then with the vacant cell XC, then with this vacant cell YA, and the vacant cell ZB. But actually you can start with any of the vacant cells. For this vacant cell, we will trace a closed path that will start from this vacant cell, and we should be able to end at the same vacant cell XB. And the closed path, as we said in the previous lesson, consists of alternating horizontal and vertical movements, the first move of which is always horizontal, either to the left or to the right, and followed by vertical movement, either upward or downward. And for each movement, there is a corresponding cost. For horizontal cost, the cost associated with horizontal movement is the positive of the cell cost from which you started, from which you came from. And for the cost associated with vertical movement is the negative of the cell cost from which you originated. For this vacant cell, we start with horizontal movement, and we cannot move to the right because it's vacant. As we said from the previous lesson, we should always land on an occupied cell. Thus, from this vacant cell XB, we move horizontally to the left. And the cost associated for the horizontal movement to the left is the positive of the cell cost for this cell, 7. After the horizontal movement, the next move is vertical. And we cannot move vertically upward because this is the demand for A. So we move vertically downward, but we do not move to this cell because it is vacant. So from 7 to 8, we skip this vacant cell and we go straight to 9 from 7 to 8. From 7 to 8, we move vertically downward to 9, and the cost associated with this vertical movement is the negative of this cell cost, negative 10. We write minus 10. So we have horizontal movement to the left, vertically downward. Now the next move is horizontal. And we do not move horizontally to the left because this is the supplier C. From 9, we move horizontally to the right. Again, we skip this cell because it is vacant. Thus, from 9, we go straight to 84. And for this horizontal movement to the right, from 9 to 84, the cost is the positive cell cost from which we came from, this cell. The cost is plus 6. After the horizontal movement, The next move is vertical. Of course, we cannot move downward. We will be out of the transportation table. So we move vertically upward. But we do not move up to this cell because it is vacant. From 84, we move vertically upward up to 11. And the cost associated with this vertical movement upward is the negative of this cell cost. We write minus 13. And after this vertical movement, the next move is horizontal. And we do not move to the right because this is the supplies of supplier Y. So from 11, we move horizontally to the left. And we do not move up to this cell because it is vacant. From 11, we move horizontally to the left up to 124. And the cost associated with this horizontal movement to the left is the positive of this cell cost. And we write plus 8. And from 24, the next move is vertical. If you move downward, it is vacant. If you move upward, you go back to your point of origin, the vacant cell XB. Hence, from 24, we move vertically upward. And for this vertical movement upward, the cost associated cost is the negative of this cell cost. We write minus 12. Again, the closed path for the vacant cell XB, horizontal to the left up to 78, vertically downward up to 9, horizontally to the right up to 84, vertically upward up to 11, horizontally to the left up to 124, and vertically upward back to where we started, the vacant cell XB. Now we calculate the net cell cost for this vacant cell XB. We have 7 minus 10 is negative 3, plus 6 is 3. 3 minus 13 is negative 10. Negative 10 plus 8 is negative 2. Negative 2 minus 12 is negative 14. The net cell cost for this vacant cell is negative 14, which means that if we transfer some units to this vacant cell XB, the transportation cost of 3,502 will decrease by 14 pesos per unit. That is, if you transfer 2 units to this vacant cell XB, the transportation cost 3,502 will decrease by 14 times 2 or 28 pesos. But we will not yet transfer some units to this vacant cell XB because we still have other vacant cells to consider. The next vacant cell is XC, and again we trace a closed path for the vacant cell XC. Again, the first move is horizontal, and we do not move horizontally to the right because these are the supplies of supplier X. Hence, from XC, we move horizontally to the left, but we do not stop at this cell because it is vacant. Thus, from this vacant cell XC, we move straight to 78. And the cost associated with this horizontal movement is the positive of this cell cost 9. So from this vacant cell XC, we move horizontally to the left. And the next move is vertical. And we cannot move upward because this is the demand of customer A. So from 7 to 8, we move vertically downward and we skip this cell because it is vacant. From 7 to 8, we go straight to 9. And for this vertical movement, the cost associated is the negative of this cell cost. In here, we write minus 10. So from XC, we move horizontally to the left, vertically downward, and the next move is horizontal. And we cannot move horizontally to the left because this is a plier C. We move horizontally to the right, we skip this vacant cell. From 9, we go straight to 84. And the cost associated with this horizontal movement to the right is the positive of this cell cost plus 6. From 84, the next move is vertical. If you move from 84 to 11, the next move is horizontal. You move to 124, the next move is vertical, and this is vacant, and this is vacant. Hence, from 84, if you move vertically upward up to 11, you will not be able to go back to this vacant cell XC. So what you do from 84, you go straight to the vacant cell XC. Skip this occupied cell. That means you can skip an occupied or occupied cell. From 84, we skip this occupied cell and we go straight to the vacant cell XC. And the cost associated with this vertical movement upward is the negative of this cost. We write minus 13. Again, the closed path for the vacant cell XC, horizontal to the left, vertically downward to 9, horizontally to the right, we skip this vacant cell, and vertically upward back to XC. We skip this occupied cell. Now we calculate the net cell cost for the vacant cell XC. We have 9 minus 10 is minus 1, plus 6 is 5. 5 minus 8 is, 5 minus 13 is negative 8. The net cell cost of minus 8 means that if you transfer some units to this vacant cell, the transportation cost of 3,502 will decrease by 8 pesos per unit. And between this cell XB and XC, it is better to transfer some units to this vacant cell XB because you will get a bigger decrease in the total transportation cost of 14 pesos per unit compared to a decrease in total transportation cost of 8 pesos per unit if you transfer some units to the vacant cell XC. But again, we will not transfer yet some units to the vacant cell XB because we still have 2 vacant cells to consider. Now we consider the vacant cell YA. This is the vacant cell YA. And the next move, the first move is horizontal. We do not move horizontally to the left because this is a plier Y. So we move horizontally to the right. If you stop at this occupied cell, the next move is vertical, and this vacant, and this vacant. So if you move from this vacant cell YA to 124, you will be lost. You will not be able to go back to this vacant cell YA. So from YA, you go straight to this occupied cell 11. We skip this occupied cell 124. From this vacant cell, we move straight horizontally to the right, straight to this occupied cell. And the cost associated with that horizontal movement to the right is the positive of this cell cost 9. The first move is horizontally to the right. From 11, we move vertically, either upward or downward. If you move vertically upward from 11 to this cell and it is vacant, we cannot do that. So that's not possible to move vertically upward from 11. From 11, we move vertically downward to 84. And the cost associated with that vertical movement from 11 to 84 is the negative of this sub cost. We write minus A. After the vertical movement from 11 to 84, the next move is horizontal, and we cannot move to 93 because this is the number of units available in supplier C. So from 84, we move straight to 9. We cannot move up to this sub because it is vacant. We skip this vacant cell, and from 84, we move straight to 9. And for that horizontal movement to the left, the cost is the positive of this cost, positive or plus 13. And we are now at 9. The next move is vertical, and we do not move downward. You will be out of the transportation table. So we move upward back to the vacant cell YA. And the cost associated with this vertical movement upward is the negative of this sub cost. The negative of the sub cost for this cell, minus 6. Again, the close spot for the vacant cell YA, the first move is horizontal to the right up to 11, vertically downward to 84, horizontally to the left up to 9, and back by vertical movement from 9 back to this vacant cell YA. We find the net cell cost for this vacant cell. We have 9 minus 8 is 1, 1 plus 13 is 14, and 14 minus 6 is 8. The net cell cost for the vacant cell YA is positive 8. That means if you transfer some units to this vacant cell YA, the transportation cost of 3,502 will increase by 8 pesos per unit. Thus, we will not move or transfer some units to this vacant cell YA because the transportation cost will increase by 8 pesos per unit, and that's not our objective. Our objective is to find the minimum transportation cost. So far, it's still best to transfer some units to the vacant cell XB. But we still have one vacant cell to consider, ZV. This is the vacant cell ZV. The first move is horizontal. We trace a close spot for the vacant cell ZV. The first move is horizontal. You can move to the right. It's okay. It's occupied. You can move to the left. That's okay, it's occupied. But if you move horizontally to the left, the next move is vertical. If you move up to here, you cannot do that because it's vacant. So from 9, you move vertically upward up to 78. But the next move is horizontal. To the right, it's vacant. From 78, straight to this cell, it's still vacant. So it's not possible to move horizontally to the left because you will not be able to go back to this vacant cell ZB. Thus from CB, we move horizontally to the right up to 84. And for this horizontal movement to the right, the cost associated is positive 11. After the horizontal movement to the right, the next move is vertical. If you move straight to this cell, that you cannot do that because this is vacant cell. So from 84, we move vertically upward up to 11. And the cost associated with this vertical movement from 84 to 11 is the negative of this cell cost, negative or minus 13. And after the vertical movement, the next move is horizontal. And we do not move horizontally to the right because this is the number of units available in supplier Y. Hence, from 11, we move horizontally to the left. And if you cannot move to this cell because it's vacant. So from 11, we move horizontally to the left up to 124. And for the horizontal movement to the left from 11 to 124, the cost associated is the positive of this cell cost. We write here plus 8. And after this horizontal movement, the next move is vertical. Not upward because this is vacant, but we move vertically downward and we are back to where we started the vacant cell CB. The cost associated with this vertical movement from 124 and back to this vacant cell CB is the negative of this cell cost, minus 12. Again, we trace the closed path for the vacant cell ZB. Horizontal to the right to 84, vertically upward to 11, horizontal to the left to 124, and vertically downward back to the vacant cell ZB. We calculate the net cell cost for this vacant cell. We have 11 minus 13 is negative 2. Negative 2 plus 8 is 6. 6 minus 12 is negative 6. Again, the net cell cost of negative 6, that means that if you transfer some units to this vacant cell ZB, the transportation cost of 3,502 will decrease by 6 pesos per unit. So you consider only the cell cost with negative, you only consider the vacant cells with negative cell costs. We have XB, negative cell cost of negative 14. The vacant cell XC with negative cell cost of minus 8. And the vacant cell CB with negative cell cost of minus 6. And among these three vacant cells with negative cell cost, the vacant cell with the most negative net cell cost is XB. This is the most negative net cell cost, which means that the greatest decrease in the total transportation cost will be obtained if you transfer some units to the vacant cell XB. And the highest decrease in the total transportation cost is 14 pesos per unit that you transfer to this vacant cell XB. Now we know that we have to transfer some units to this vacant cell XB, and we are now ready to develop the third transportation table. We will now develop the third transportation table because we will now transfer some units to the vacant cell XB. That will give us a decrease of 14 pesos per unit that we will transfer to the vacant cell XB. And I write again the path for the vacant cell XB. the closed path consisting of alternating horizontal and vertical movements. Those numbers in the occupied cell that are not in the closed path for the vacant cell XB will remain the same in the new transportation table. But for the vacant cell XB, you can see that all these numbers in the occupied cell are within the closed path for the vacant cell XB. That means that all these numbers, 78, 9, 84, 11, 124, and this is a vacant cell initially, it has 0. All these numbers will have to change. And how do we know the number of units to transfer to this vacant cell? We consider the vertical movements upward and downward. For this vertical movement downward, we originated from 78. From this occupied cell, we move vertically upward and we originated from 84. And this is another vertical movement upward. We originated from 124. Now, one of these numbers has to be transferred to this vacant cell XB. If you transfer all of these 124 units to this vacant cell, you will satisfy the demand of B. But 124 cannot be taken, all of 124 cannot be taken from supplier X, because supplier X has only 78 units. It's the same with 84. If you transfer all of these units to this vacant cell XB, you will satisfy most of the demand of customer B, but you cannot take 84, all of 84 from supplier X that has only 78 units. So we transfer 78 to this vacant cell, and this 78 will now become 0. 78 will be transferred to the vacant cell XB in the third transportation table. Because we have moved 78 units to this vacant cell, 124 has to change. And what number should be written here? 124 minus 78. You may use your calculator, or you can do it like this manually. 124 minus 78 is 46. So this 124 will now change to 46 units in the cell YB. YB 46. Because we change 124 to 46, 11 will also change. And how many units are to be placed now in this cell YC? You have 135 minus 46. 135 minus 46. 135 minus 46 is 89 units. So 11 now will be changed to 89 units in the cell YC. And because We have changed 11, we also have to change 84. And the number to be placed, to be written in this cell C is 95 minus 89. And we have 95 minus 89 is 6 units. 84 now, we'll have to change to 6 in the cell ZC. And 9 has to also change to what number? 93 minus 6. And 93 minus 6 is 87 units. So in the cell ZA, you now write 87 units. ZA, 87 units. And 78 now becomes 0 in the third transportation table because we move all of 78 units to the vacant cell XD. Now you check your third transportation table if you have written the correct number of units. Add the numbers vertically downward. 87 plus 0 plus 0, 87. Add the numbers in vertical direction. 0 plus 46 plus 78 is 124. 6 plus 89 is 95. Also add the numbers horizontally. 0 plus 78 plus 0 is 78. 0 plus 46 plus 89 is 135. 87 plus 0 plus 6 is 93. And this is our third transportation table from which we will now develop the corresponding third distribution plan. We now develop the third distribution plan corresponding to this third transportation table. In the first column, we write the supplier, followed by demand, the number of units to be supplied, the cost per unit, and the total cost. We start from supplier X to customer B. We supply 78 units at 7 pesos per unit. And we find the total cost of supplying 78 units at 7 pesos per unit from supplier X to customer B by multiplying 78 by 7. And use your calculator. 78 by 7 is 546. From supplier Y to customer B, we supply 46 units at 12 pesos per unit. And we also compute the total cost of transporting 46 units at 12 pesos per unit from supplier Y to customer B by multiplying 46 by 12. We have 46 multiplied by 12, we get 552. And from the same supplier Y to customer C, we supply 89 units at 8 pesos per unit. And we find the total cost of supplying 89 units 89 units from supplier Y to customer C at transportation cost of 8 pesos per unit by multiplying 89 by 8. Multiply 89 by 8. And you should get 702 pesos. Sorry, 712 pesos. Let us check. 89 multiplied by 8. 712 pesos. And from supplier Z to customer A, C to A, we supply 87 units at 6 pesos per unit. And we find the total cost of transporting 87 units at 6 pesos per unit from supplier C to customer A by multiplying 87 by 6. And we get 522. Lastly, from the same supplier C, we supply 6 units, transportation cost of 13 pesos per unit to customer C. We have Z to C, and we find the total cost of transporting 6 units, transportation cost of 13 pesos per unit from supplier C to customer C. Multiply 6 by 13. And you should get 78. And we add the last column to get the total transportation cost for the third distribution plan. We have 546 plus 552. 546 plus 552 plus 712 plus 522 plus 78. And we get 2,410. Now you can see that the transportation cost decreased from 3,502 for the second transportation table to 2,410 for the third transportation table. Now we check if this third transportation cost is correct. we check if the total transportation cost we obtained for the third distribution plan is correct. The old transportation cost is the second transportation cost of 3,502. From our test from our test for improvement, the decrease in transportation cost per unit if we transfer some units to this vacant cell XB is 14 pesos per unit, denoted by negative 14. This is the net cell cost of the vacant cell XB from the second transportation table. And the number of units we transferred to the vacant cell XB is 78. Thus, the total decrease in the transportation cost is the number of units transferred, 78, multiplied by the decrease in total transportation cost per unit of 14 pesos. 78 multiplied by negative 14 is negative 1,092 pesos. And we subtract this because it is a decrease from the old transportation cost or the second transportation cost of 3,502 minus the total decrease in total transportation cost of 1,092. 3,502 minus 1,092 is 2,410 pesos, which is the third transportation cost. So this transportation cost of 2,410 pesos is correct. This is the transportation cost for the third distribution plan that corresponds to the third transportation table. Now, we will do again the test for improvement to check if we can still decrease or lower this transportation cost of 2,410. And for the test for improvement, we consider again the vacant cells, this vacant cell XA, XC, YA, and CB. If we still have a negative net cell cost in the test for improvement, that means that the solution is not yet complete. But if in the test for improvement, all the net cell costs are either 0 or positive, then the solution is complete.